About 1 year ago, I created a very long and detailed video about my final programming project for my class. And I enjoy making it. And I got a lot of personal comments from my friends and family saying that they loved the video, including my teacher who actually taught the class. And I want to do that again, but I don't know what to do it on. Well, guess I better spend some time thinking about it later. I miss the old Pokemon games.
Many months later.
What the hell am I doing? Fine, I'll do Pokemon. Well. After a year has passed, it is time to start on this next project in recreating a classic Pokemon game. Now, for completely legal reasons, I just want to say that I am not going to release this code out to the public, because I fear that the Pokemon assassins will put a target on my head if I do. So, Pokemon Company, consider my plea. Hi, I'm just a dumbass college student with way too much free time on my hands to be hit by a lawsuit. So please be nice to me, Pokemon Company. Also, I collect your merchandise for fun, so I already gave you over $1,000 of my already small bank account. So, hope you don't get mad at me. An email from the Pokemon Center. Why did this to me? Now some quick pointers before we start. Just like in my last video, this project will be completely programmed in Java. No game engine will be used. Also, this program and this video will be only created by me. I tried asking a few friends, they're all busy. Tried calling my friend Ryan, he won't even pick up the phone, probably for ratting him out in the last video. So that means I'm all alone in this project. That means I need to use my current skills with Google and Java to complete this project. So, I guess it's time to start this program. Alright, part 1. Let's do this. So, this will be more of the planning part of the video, so let's start with that. The first question is, what game will I be replicating? I can work with the messy red and blue games, or the more enhanced diamond and pearl games. While these games are great, I don't think both of them would be good fits. The first generation is pretty dated for me, and I also want to work with other generations that have my favorite Pokemon in it, rather than just the original 151 Pokemon. And the 4th gen is a bit confusing since this did come out during the DS era. Trying to implement the 2-screen that the DS came with is not what I want to focus on. So the game I will be replicating is my favorite Pokemon game, and I know a fan favorite for most, is Pokemon Emerald. The Hoenn region. The region with arguably the best starter trio, the 2 villain teams, and of course, the place that has too much water. Now, I picked this game for a few reasons. It is my personal favorite Pokemon game. The intro to this game is quick and takes no time to get into the action, unlike some other games. And there are a few problems in the game that I can personally fix to make the game a bit better. And I'm sorry for saying this, but I'm not making the entirety of Pokemon Emerald. So instead, I decided to do only up to the first 4 gyms. So right here, I have the entirety of the Hoenn region routes just connected to each other. So, as you can see, this includes the entire map, not including any of the interiors or the caves or dive spots. So I'm showing you this map because if you can see these faint blue lines right here, and that's an indicator of what quadrants we're going to be doing. And since this bottom left one is the starting quadrant, that's what I'm going to be doing. So here's a closer version of that, and as you can see, here's your starting area and your gyms, which this is technically the 5th gym, but it's going to be the last gym. But you have the 1st, 2nd, 3rd, and then this one was the 4th gym in here. And even though this gym right here is supposed to be the 4th one, but since we're not including this part of the map, we're just going to be making this gym the 4th one. I'm only showing you this just to get an understanding of how big this part of the map is. Alright, with that being said, let's start this. So we'll quickly make the window and the panel, and there we go. Part 1 is done. So, I will be making a bunch of comparisons to my last project I made, so I recommend you watch that video to get a basic idea of what my current level of programming is. In short, these two games are completely different. There are two major parts of this game that is completely different to a standard Pokemon game. One reason is that in this game, you are completely static. The only thing that you can do is rotate the tank that follows your cursor, which fundamentally only makes the player think that they're actually controlling the tank, when in reality the hitbox for the tank never moves. But in Pokemon, you have complete freedom to move around and explore the world. Second is that this game only has one screen, while in Pokemon there are many screens that you have to deal with. For controlling, battling, or many UI windows you have to traverse through. Now, let's get into what making a game is all about. I did not talk about this in the last video, but I'll discuss it here because of its major importance to game design. So, let me ask you a question. What is required to make a game in any programming language? What every game needs is a game loop. Now, what is a game loop? A game loop is a continuous cycle that keeps the game running and handles the logic of the game. This loop handles player movement, checking logic for the game, and any background elements like NPCs or any other animations. Each iteration of the loop is what's called a frame, and it's used to check for any part of the game that needs to be updated. Like, for example, player inputs. Then, the computer outputs the updated image onto the screen for the player to see. Now, the time for how long a frame takes depends on how powerful the hardware is. So the frame rate can be consistent every time, but the typical frame rate is either 30 or 60. For this program, I'll settle for 60 frames per second. Now, if you saw at the end of the last part, I put in a simple square. This square is going to be used to test for the input commands. If the user presses the WASD or the arrow keys, then the square should move in that direction. So, now that we have all the variables, let's try it. So, it seems that the keyboard input is too fast. The reason it's too fast is that the game is running the game loop every nanosecond at a time. To show you how fast that is, here is every nanotime displayed every nanosecond. The problem is that the actual game loop itself is not running in the steady 60 frames per second. But how do we actually do that? Well, let me introduce the delta method. The delta method uses a delta time, which is the amount of time passed since the last frame, We get this by subtracting the current time by the previous time, so we can get a fixed time. We then divide by a variable called a game time, which is the amount of nanoseconds, and a second divided by the frames per second. Once the delta reaches a time of 1, then the game is updated and repainted, and a delta gets reset, causing the game loop to be at consistent 60 frames per second. So instead of the square moving every nanosecond the key is held in, it should now only move at slower speed so we can see it and control it more. And now we can actually make the square into the basic character the player can control. And a quick update. I want to explain what I'm going to do with the sprites. Since this is a recreation project and not an original project, I decided and the best way to save time is to basically take old sprites that have been ripped from the game and use those in this project. And to be fair, I am not the greatest sprite artist, and I figure most people would just prefer the original art of the game as well. Even though in my last video, I did make a reference to Pokemon, instead of doing fully custom sprites for everything, it's just easier to rip it from the game assets. And nearly most of the sprites in the game have been used in Pokemon Emerald. And one other thing, I am not a great animator, so most of the animations probably don't look as good as the actual Pokemon games. And I don't really want to focus on animation since this is more of a programming thing, not an animation project. So back to the original topic. Now using the pre-made sprites for the player character, we can initiate the player sprites. Since there are 4 directions, we need to only get the player in 3 directions. Since the left and right one can be easily flipped to move in the opposite direction, so we don't need to make a custom one for both left and right. Since we have the character moving, we need 3 more sprites for each direction for animation as well. Now the idea for moving a sprite in animation can be a bit tricky since the frame rate may be too fast for the character, so we may need to tone down the speed of the frames. Now for each direction, there are 3 frames that we need to deal with. Frame 1, frame 2, and the frame I like to call the idle frame, which can be used for not moving and in between frame 1 and 2. Now, if we want the character to move correctly, we need to do the frames in order by frame 1, idle, frame 2. Now, because this game runs on 60 frames per second, we need to adjust these sprites to be displayed at the right time to give the player more of a movement field. We also have the idle frame, which is the frame we want to be on when the character is not moving at all. Now, a big problem is that the character is just walking in the void, which is not very pleasing. So, let's change that. Now, to understand how we can get the background to change to a more pleasing and understanding way, there needs to be some form of map for the player to adventure through. To go about this, the old Pokemon games use what I like to call a tile-based structure, where many rectangular tiles are placed on a grid to form a playing area. In Pokemon Emerald, these tiles are all 16 by 16 pixels that are scaled with everything else. So we can grab a small tile and draw on the first square. Now if we want to draw more tiles, we just need to move the X or Y value of each tile to create a small area of tiles. And you're probably thinking that this method of placing tiles would take forever to do. And you're exactly right. I do not have the patience to draw every single tile position on a map and fill in every single 100 different tiles, most of which aren't even visible to a player within the screen's width. There needs to be a better way to fill in every single tile without me going insane. But with my understanding of programming, there is always an easier way to do this. Remember those coloring books from kindergarten, where each object or border there is a number, and in the margins of the page, a specific color is marked with that number, and you fill in each section matching the number with the right color to create the colored picture. Now, why am I mentioning this? Well, imagine you have a blank picture. That is our uncolored map. Instead of colors, each number corresponds to a different type of tile. Our job is to color this map with the right tiles based on their tile number in the code. How do we code this in? Well, in our code, we have something called a tile manager. It knows every tile we need and where each one goes on our game map. First, we need to get all our pieces ready. We do this by loading images for each tile from a file. These are our pieces. Each image represents a different terrain: grass, water, path, anything. Now, to put the puzzle together, we read from a map file. This file is full of numbers that tells the program where it should put the tile. Once we know where each tile goes, it's time to draw them on the screen. We carefully place each tile in its right spot based on the map instructions, creating our game world one piece at a time. Now, there are special tiles in the game, like slopes, tall grass, and tiles that cannot be passed through. Now, this is not as hard as it may seem. See, there is also a tile class that includes Boolean value for tile properties for each separate tile. So instead of having each tile placed one at a time, the program has a file, which is a map, so it knows which tile goes where. Now that the map is fully complete, we can now move the character throughout the world. But wait, there is still one important detail I have yet to mention. The camera. Let's talk about bringing our game world to life on your screen. It's all about the camera system. In our game, every tile has two important addresses. One is its world address, where it is on the map. The other is its screen address, where it shows up on your screen. Our job is to make sure each tile knows where to be at the right time. Let's say you're staying on the X coordinate of 500 and the Y of 500. That's your world position. Your window or screen lets you only see a few blocks around you. So a tile that is 0, 0 will not be visible because it is too far away. We calculate this in the game and only draw the blocks that are within your view to make everything run smoothly. But here's another thing. We don't want to waste our time drawing what's not in the camera's view. This means we don't draw tiles that should be too far from the player. We're going to set boundaries so that the program will not draw something that's too far left, right, up, or down from the player. This way, our game should run smoother and focus on what you, the player, sees. There is one more thing that needs to be talked about in this section. The special tiles, specifically collision. The idea is simple. Since we have the entire world created, we do not want the player to freely walk around everywhere. Not only would this be clunky, but it skips entire parts of the game. So the idea is to make collision. Now, to understand this, we need to create what's called a hitbox. Now, for clarification, the hitbox is not the same as the image. This is because the image is much bigger than what is seen in the game. And if the player is not allowed to pass through objects with collision, it can seem that the character is not even touching said tile, because even the tiniest corners touching a tile with collision can force the character not to move. If I adjust the hitbox to be more inside the player, it makes it much easier to move around the world, and moments where it feels like the player is stuck to be less common. This is not too difficult to program. We just need to know if the tile from the direction the player is moving has collision. If it does, the program will not allow the player to walk over it. And that's basically it. The one thing I can mention are these slope tiles, which only allows one direction, and basically all I did was remove the collision if the player is moving in that direction. So we built our world and set the rules for where our player can go. But it's just empty. No objects, people, or Pokemon. Since we have this world created, it's best that we have some sort of life into the game. Let's start this by adding simple objects into the game. Since the term object means so many things in programming, let's define this in a way that makes sense in this game. An object is any form of interactable the player can interact with. This can be an NPC or an object on the ground or any part of the scenery. It doesn't need to be visible. Let's start with the simple pickups. Pickups in Pokemon are usually represented as Pokeballs in the overworld. You see it and open it to find things you already have plenty of. So, similar to the tiles, we need to know the image and the location of the object. However, we also need to know what's in the object and how many of said object are in the ball. We then put in the X and Y values, which the program will draw on the screen at that location. For the player to pick up the object, we use a similar method to check the collision to see if the player is on that object. The function will then return the number value of said object, and the object is collected by the player. The pickup item is also being set to null, so you can't pick it up multiple times. As for the NPCs, they are a bit more complex. NPCs are similar to the player in that they need the same functions, like the images for the 4 directions, including walking frames, and hitboxes. Also, nearly all NPCs have dialogue, so we need to figure out how to implement this dialogue option. To touch a bit on dialogue, the method for interacting with some NPCs is a bit different. For most NPCs, they just have the dialogue box go into a different piece of dialogue, and some that you can interact with, from answering a simple question, whether you want to rest, trade, or answer a question that makes no sense. To do this, we use an array to create a full dialogue tree for any NPC to respond to. However, some NPCs can also turn or walk around, so it's good to give the NPCs more freedom to move around. There's a lot more that goes into NPCs, but currently they need more work to get done, so I'll discuss some later. The last thing I want to discuss are events. Events are any form of occurrence that happens when you step on a specific tile. They can happen once or every time the player steps on a tile. Something like a cutscene or random phone call should only happen once, while something like a tile that teleports you somewhere should happen around every time. All three of these parts provide more ideas to create the world, and all of them need more work. But I think it's time to finally talk about the main reason why you click on this video. It's time to work on the first question that comes to mind is, what should I do first in order to start implementing the Pokemon? I want to separate this into 2 different topics. What do all Pokemon share, and what makes a single Pokemon unique from all the others? Like this guy, what sort of thing makes him different from every single other Pokemon? My idea is that each Pokemon will have its own subclass while it inherits everything in common with every Pokemon, a class called Pokémon. Now that will be a lot of classes, so it's best to make sure it works with just one Pokemon before we start to implement the rest. So I hope you really like or hate Bulbasaur, because we'll be just about testing everything or mutilating just about everything on him. So let's make a list of what every Pokemon shares at least some form of, and what each individual Pokemon has that's different from most Pokemon. Let's start with the obvious. Every single Pokemon has some sort of ID. The ID, or most commonly known as the Pokédex number, is the number that indicates what Pokemon it is. Not the name, not the species, but the ID. Another common thing that all Pokemon share, at least one of, are types. Now every Pokemon has at least one type, some even have two, and those types are normal, fire, water, electric, grass, ice, fighting, poison, ground, flying, psychic, bug, rock, ghost, dragon, dark, and steel. Not doing fairy. It doesn't exist. Some more things Pokemon share are genders, either male, female, or unknown. All Pokemon have some form of leveling up, and generally it's different from some Pokemon, but all Pokemon do share a leveling. All Pokemon have moves. Some are different, but a lot of them share between different Pokemon. And all Pokemon have some sort of sprite images to represent them. And there's a lot of hidden stats between Pokemon that are generally not really shown. For example, certain Pokemon have different experience drops. It's never stated, but I'm pretty sure most people know that it's obvious that you get more XP when defeating a Dragonite rather than the Caterpie. One of the more confusing parts of Pokemon are the stats. Generally, when you go and look up the stats of a Pokemon, you find this table with numbers that correspond to each stat. And when you check the game, you see that the stats are nothing alike. But you generally do know that the higher the number on the website does correspond to a better score for your actual stats. Well, the stats you looked up is actually what is known as base stats. And that corresponds to how you actually get your formula for your stats. The formula for the stats are, for HP, it's 2 times the base, plus the IV plus EV all over 4, all divided by 100, plus the level plus 10. And for all other stats, it's 2 times the base, plus the IV plus the EV, times the level all over 100, plus 5 times the nature. Now all Pokemon shares this formula, except for one, which does not follow the health formula. I'll let you figure out which Pokemon that is. And generally, what are these values EV and IV? And what does the nature do, and why is it on HP? Well, the terms IV and EV stand for individual values and effort values. Individual values are values that the Pokemon have between the range of 0 and 31. Each Pokemon gets a random number between these ranges, and they cannot be changed at all. Effort values, on the other hand, are stats that the Pokemon obtain when defeating a Pokemon. Each spawn gives a different value to a different stat. So when you decide to kill a random rat hiding in the grass, you get a small bonus to your speed. The thing about EVs is that each individual stat has a maximum of 252 EV, and the Pokemon can have only a max of 510 EVs total. So now we need to keep track of EVs and IVs, and each Pokemon yields some amount of EVs when defeated. They also don't need to be the same stat. They can increase the EVs of different stats as well. As for the nature, some nature provides a special bonus to one of the Pokemon stat while hindering a different stat. In Emerald, there are 24 different natures that correspond to increasing a stat while decreasing a stat, or the nature does not affect any of the stats, making the last part of this formula useless. Now if the nature does value the stat, then the ending of the stat gets a 10% bonus. And if it hinders it, it gets a 10% downgrade. So either the stats are multiplied by 1.1 or 0.9 depending on the bonus or not. As for why it doesn't affect HP, it's so that every level up guarantees an increase in the Pokemon's HP. So now that you have all the values, let's calculate the total stats of Squirtle right here. So here are all the base stats for Squirtle. We have 44 for HP, 48 for attack, 65 for defense, 50 for special attack, 64 for special defense, and 43 for speed. Considering that all IVs are randomized, let's just randomize numbers right now. And let's assume the Squirtle has a quiet nature, which as you can see, increase special attack and decrease speed. And we can assume that the level is 5, and since it hasn't been in battle, it hasn't heard any EV, so technically all EVs are 0. And our final stat totals are of this Squirtle that's level 5, have these IVs, quiet nature, is 20 HP, 10 attack, 12 defense, 11 special attack, 12 special defense, and 9 speed. And just to mention, in Pokemon there's no decimals, so even if there is a decimal, it'll always be rounded down. So that's how you calculate stats for every Pokemon in the game. There is one thing to mention, which are stat modifiers, but I'll discuss those when talking about battling. Before we actually get into battling, the one thing I want to talk about is leveling. One of the main aspects of Pokemon comes in the form of training and leveling up your Pokemon. You may think that leveling is just a simple linear graph every time. Well, you cannot be more wrong. In Pokemon, each Pokemon gets assigned a growth rate similar to how strong its power level or how weak it is. Simple Pokemon you find in the beginning generally have an easier time of leveling up than the late game Pokemon. So, how would you like your Pokemon? Fast, medium slow, or slow? And before you say it, yes, I know there are 2 other experience groups. Both of them are complete shit and only feature a small handful of Pokemon, so both of them have been removed. Some of the level up categories have a simple formula to follow, like the medium fast, which is just at the next level cubed. And some are a bit more complex, like for the medium slow, it's 6 over 5 n cubed minus 15 n squared minus 100 n minus 140. How the hell did they come up with that formula? So here are the main formulas for each of the 4 categories. Now to get the experience for the next level, you just take n plus 1, apply it to the n, and that's how much experience you need to get to level up to the next level. So the question is, how much experience do you actually get in battle? And to answer that, again, it's complicated. Now, this formula is a little old, because the newer Pokemon games use a bit more, but just generally is the main formula. That is, B times L all over 7 times 1 over S times A times E times T. And fear not, I'll go over what each variable means. The B represents the base experience drop that every Pokemon drops. Every single Pokemon has that, so that's another variable we need to keep track of. The L stands for level, pretty self-explanatory. Now, S is the number of Pokemon that have participated in that battle. If all Pokemon have participated, this will be up to 5. Now the value of A changes. If you're fighting a trainer, it goes to 1.5, a wild Pokemon it's at 1. And the value of E says if you're holding the lucky egg. And the value of T is determined by if the Pokemon has been traded. Meaning that if it was a traded Pokemon, it will be a bit different. So this is the main formula we really deal with in the Pokemon game. Then the XP is given to every single Pokemon that participated in battle. Speaking of battling, There's a lot that goes with battling. To start, let's talk about the different types of battling. The two main battle types are wild and trainer battles. We will mainly focus on wild battles for this video. To initiate a wild battle, the player must do something that is too troubling for the special gamer: touch grass. So what I did is I made all tall grass tiles have a unique effect. So the effect that handles collision also checks if the tile is on the grass. If it is, it triggers the touch grass method, and if the trigger hits the correct number, it starts a wild battle. But what Pokemon will the player be facing? Well, according to the web, certain routes have a different amount of Pokemon and a percentage chance of how likely that Pokemon will be encountered. There's also a range of numbers that the Pokemon level could be. So we got the wild Pokemon, and the lead Pokemon in your team is always the one who's attacking. First thing you see are 4 options: fight, bag, Pokemon, and run. The bag focuses on items, which will be talked about in the next part. The Pokemon checks the team and is how you switch the mons during battle. And the run button is what you press when you're too much of a coward. Now for the fight. In Pokemon, the mons can only have up to 4 moves. Each move have a type and PP. The amount of times you can use the move until you have to run to a Poke Center or use some items to increase it. Now, here's where it gets complicated. You see, there is a bit of a problem that needs to be looked at. If you know anything about programming, you will notice that the speed that the attacking state will be in is mostly instant. So we need to time the events in battle to be in complete order. Now here is the order of what the combat should be. First, get the move from both Pokemon. Second, consider which Pokemon's move will go first. Third, the first Pokemon use their selective move now. Fourth, apply any additional effect that the move has applied. Fifth, check if the mon who was attacked is still alive. If not, skip number 6. Step 6. Do rules 3 and 4 for the opposing Pokemon. 7th. Do end of turn effects, like poison or any burn damage. 8th. If Pokemon are still alive, return to the initial battle menu and restart to the first step. If the opposing Pokemon is fainted, reward EXP to the mons that have participated, and end the battle if the Pokemon is wild. If the player Pokemon has fainted, pull up the team screen and force the player to switch in to any mon that can be switched in. If no Pokemon can be switched in, then the player wipes and gets sent to the last safe location. Now let's discuss each step one by one. To get the move from each Pokemon, the player chooses one of the moves on the list. If the move has 0 PP, the player cannot use that move. If all moves have 0 PP, then the Pokemon is forced to use the move Struggle. Switching, using an item, and attempting to run are all considered moves. They also always have the highest priority, meaning they will always go first. To get the opponent's move, it's determined by the type of opponent. Most of the time, it's random. And yes, the PP does decrease for the enemy as well. So if the enemy has 0 PP on all of its moves, it will use the move Struggle. Second, to see which Pokemon goes first, you check the move priority and determine which mon will go first. If they are equal, then the Pokemon with the higher speed will go first. We just talked about how we get the speed in the last part, so we can bear both Pokemon's speed, and then that Pokemon goes first. If both speeds are equal, then the Pokemon that goes first is determined by a coin flip. Steps 3 and 4 are going to take a while, so consider this a mini part of the video. Hello and welcome to part whatever of this video, where we're going to be talking about moves. Now I need to separate the moves into a different class to make it more organized. Even though taking a handful of spaghetti from one plate to a different plate just means I have 2 plates of spaghetti, well hey, at least it's organized. Anyways, each move has properties of their own, which are ID, name, power, PP, accuracy, priority, type, description, and category. First thing I want to talk about is the category, which can either be one of 3 things: physical, special, or status. Notice that the physical and special are the attacks and moves that do damage, and status is what doesn't do any damage. The attacking moves depend on which stat it will use. If it's physical, it'll use the attack and defense. If it's special, it'll use the special attack and special defense stats. Also, from the early generations of Pokemon from Generation 1 to 3, they had this weird property that if you are one of these types, you would always be considered special, and the types not listed here are always considered physical. This raises a weird question because of the move, like the name of Fire Punch, which is a fire move, or Fight, which is a dark move, are clearly physical, but since they belong in these types, they are always considered special, which makes no sense. So in Generation 4, they had this thing where they split every single move into physical and special based on a name and not the type, meaning that they took Game Freak 10 years to figure out how to do this properly. Well, it took me 5 seconds. So in Emerald, even though the category is based on the type, I changed it so now the category is based on the name of the move and not the type. Basically what the current move is today in every single Pokemon game after. To determine if the move actually does damage or affects the Pokemon, we need to determine if it actually hits the Pokemon. To find out if the move will hit or not, we need to do math to figure out the probability of it actually hitting. Now I forgot to mention 2 stats that all Pokemon do in fact share, and that is accuracy and evasion. These moves can be increased, so I have to include them. To figure out if the move actually hits, we use this formula. So we have the hit chance, which is equal to the accuracy of the move as a percent, times the accuracy of the attacking Pokemon, divided by the evasion of the defending Pokemon. We then get a random number between 0 and 1, and if this number is less than or equal to the hit chance, then the move will hit. There are a few moves in the game that are guaranteed to hit, so they will actually have an accuracy of 101, which guarantees they will always hit. Now that the move actually hits, we need to calculate how much damage the opposing Pokemon will take. Similar to the Pokemon stats, I'm going to show you the formula for how you get the damage, and I'm going to go over every single variable, and provide an example similar to how I did the last one. So, the formula to how to get damage is 2 times the level divided by 5 plus 2 times the power times the attack divided by defense, all that divided by 50, plus 2 times crit times double damage times burn times stab times screen times type times a random number between 85 and 100 divided by 100. So crit has a random chance of happening. There is a 1 out of 16% chance to actually crit, which will be equal to 2. Otherwise, it's always equal to 1. Double damage is determined by effects of certain moves. For example, if the Pokemon uses the move Dig and is underground, if the opposing Pokemon uses the move Earthquake or Magnitude, this move will always hit and will actually do 2 instead of 1. There are other moves that have this effect. This is just one example, but that's how double damage works. The burn variable says that if the attacker is burned and the move is physical, then the variable will equal 0.5, otherwise it equals 1. Now even though it's funny to imagine a Pokemon pulling out a knife and stabbing the Pokemon, that's not what the stab variable means. Stab stands for same type attack bonus. If the typing of the move matches the typing of the Pokemon, then that variable equals 1.5. If not, it equals 1. A screen variable states that if any Pokemon has a defensive screen up. For physical, if the move Reflect was used, then it's 0.5. If special, if the move Light Screen was used, then that equals 0.5. Otherwise, it equals 1. One of the most important parts about Pokemon battling is the type effectiveness. As you can see with this chart, certain moves are always effective against Pokemon with certain types, or are ineffective, or just fully immune to certain types. Water moves are always more effective against fire types, while a fire move against a water type will not do as much damage to the Pokemon. If you are a beginning programmer, you can imagine that this would be a very long and messy if statement. Even though you can do that, there is always a faster and easier way to do this. And the easiest way? Just make the same matrix as shown here, and just get the multiplier from both the primary and secondary types. And that's how you just get the type multiplier. So instead of having over 70 lines of code checking each type against another, we just have a simple matrix which does the whole thing on its own. And that's basically the entire formula. There are a few things I omit from the formula, like weather and abilities, since those may be implemented at a later date. So let's do an example similar to the stats on the last part. Let's say that a level 5 Charmander is attacking a level 5 Squirtle. The Charmander uses the move Ember, a special fire move that has a power of 40. Since this is an example, let's say that the Charmander's attack stat is 10 and the special attack is 11, and the Squirtle has a defense and special defense stat of 11. There is no special defense screen up. Approximately how much min and max damage will the Charmander do? Since we have a level of 5 and the power is 40, we can fill these in. Since this is a special move, we will be using the special attack and special defense for the two Pokemon. I said that Charmander's special attack is 11, and Squirtle's special defense is also 11. There is no priority that this move does double damage, so the double damage is 1. I never specified that the Pokemon was burned. Even if the Pokemon was burned, it wouldn't matter since this is a special move and burn only affects moves that are physical. Also, Charmander is a fire type and fire types can't be burned, so the burn is 1. As for Stab, Charmander is using a fire type move and is in fact a fire type, so therefore Stab would equal 1.5. I clearly specified that no screen is up, so screen is equal to 1. As for type, Charmander is using a fire type move on Squirtle, who is a water type. Fire is ineffective against water types, so the type is 0.5. So finally, we can see that even if this becomes 85 or 100, it will come down to a decimal, and since this is integer math, it will always be rounded down. So the damage that a Charmander could do is 3 or 6 if the move actually crits. Now normally, I wouldn't talk about any of the bugs that happened during this project. However, this one bug I encountered still shocked me to this day, and I still have no idea why it happened. Now, assuming that you know nothing of programming, there's what we call primitive data types, and these 3 are the most common ones that I use. Now, when it comes to numbers specifically, there are ints and doubles. There are also some other like shorts, longs, floats, but these 2 are the general ones I use always. Booleans don't deal with numbers, so we're not going to focus on Booleans. Now the main thing separating between ints and doubles is the fact that ints cannot have any decimals, while doubles can. What would happen if you actually take a double and put it into an int? Would it actually work? Technically, yes. There's a single typecasting where we can actually make a double and treat it as if it were an integer, so therefore it can work. However, I said that ints can never have decimals. So what would happen if we give a decimal to an int? Well, we already went through that in this video. If any int has any form of decimal, it will always be rounded down to the whole number. Now understanding what I just said, if we go back to the type formula, you can see that if it's affected, the type will multiply by 2. If it's not affected, the type will be multiplied by 0.5. I did this formula because most Pokemon have 2 types, and therefore it can just go through this formula again. However, originally, this formula was a little bit different, and it was actually incorrect. Instead of multiplying by 0.5, I divided by 0.5. Now, if you are any good at math, you should realize that these two are the exact same thing. If you multiply by 2 or divide by 0.5, you get the exact same answer. However, that's not the problem we have here. Now, remember I said that ints can never be decimals. So if I make this actually an integer, instead of being divided by 0.5, it just simply divides by 0. Now this would be a huge problem, because, as you know, you can't divide a number by 0. And usually in programming, this would throw an error. And it did. Keyword on it did. When I was testing that formula with Pokemon that were using ineffective moves, not only was it not throwing an error, but the Pokemon would always do enough damage to save the Pokemon. And I find that kind of weird. Because why would an ineffective move always kill a Pokemon, no matter its type efficiency? And so, when I actually had the program actually give me the value, this is what it gave me. No wonder that Pokemon fucking dies. So without me even telling it to or even asking it to, it decided to follow the rules of calculus, where if you divide a number by 0, it just equals infinity, which I never told it to do, and I never asked it to do this. And I always found it weird. Why did it actually calculate infinity? Because infinity is technically not even a number, and for some reason, it just never wants to throw an error. One of the theories I have is even though that the Pokemon's taking infinity damage, that means its health will be at negative infinity. And negative infinity is less than 0, so therefore the Pokemon always faints. So I figured out the problem. Inefficient moves no longer do infinite damage, and so your Charmander is safe and can now safely touch a blade of grass without dying. Anyway, back to the battling rules. There are 2 things that need to be mentioned. First off, not all moves do damage, or even attempt to do damage. And secondly, a lot of moves do more than just do damage. Let me introduce you to 2 more important topics, that being stat modifiers and status effects. Let's discuss stat modifiers first. Now, what are stat modifiers? Well, in battle, let's say after you do an attack or some effect, it says your Pokemon's speed increase or your Pokemon's attack decrease or something similar to that. That is what's being happened here. So, stat modifiers, as you can see by the table, can go back to 6 or up 6. And every single time you actually get a stat modifier, you multiply their final stat by the fraction you see here. So whatever stage your multiplier is at, it will be multiplied by the fraction. Few things to add is that if your Pokemon switched out or fainted or anything, it will always be reverted back to 0, which could be good or bad. Now for status effects, there are 6 main status effects that we deal with. They are Burned, Frozen, Paralysis, Poison, Sleep, and Confusion. Let's discuss each of them. Let's start with Burned. Pokemon that are burned at the end of their turn takes damage equal to 1/8 of the Pokemon's max HP. Physical moves damage is halved, like we talked about earlier, and cannot be healed naturally. Fire types are also immune to burned. For Frozen, every time a frozen Pokemon attempts to move, they have a 20% chance of thawing out. If hit by any fire move, they will thaw out instantly. Ice types are immune to being frozen. Next up, we have Paralysis. The paralyzed Pokemon's speed is halved, and they have a 25% chance of not moving. Paralysis cannot heal naturally, and electric types are immune to paralysis. This was a feature added in Generation 6, but I decided to keep it in here. Next up we have Poison. Poison Pokemon take 1/8 damage of their max HP at the end of turn, similar to Burned. Poison cannot heal naturally, and poison types are immune. There is something also known as Badly Poison, which actually increases the amount of damage per turn. And to get rid of Badly Poison, you switch out your Pokemon and it will just revert back to normal poison. Next up, we have Sleep. Pokemon cannot move while asleep. Sleep can last between 1 and 5 turns. Once the Pokemon awakes, they can start freely attacking. And lastly, we have Confused. Confused Pokemon have a 50% chance of hitting themselves. The damage is the same as the physical formula, only that the power is 40, and the Pokemon cannot crit itself or do stab damage. Confusion does heal, and it takes usually between 2 to 4 turns, or when you switch out. Now those are all the basic stack effects, and how we use them in battle. Now, some moves also have some sort of unique effects. So for this last section of this part, I'm going to go over some unique parts of the first 100 moves and how I actually implement them. Double Slap and Pin Missile has a random chance of attacking 2 to 5 times. The easy part is that the damage is the same every time, unless it crits, because only the first time can crit. The percentages are 33.5% to hit twice, 33.5% to hit 3 times, 12.5% to hit 4, and 12.5% to hit all 5. Honestly, it wasn't that bad to program. Bind, Wrap, and Fire Spin all traps the opponent for 1 to 4 turns. Trapped Pokemon receive damage of 1/16 of the target's max health. The percentages are the same for Double Slap and Pin Missile, just substitute hit for turns. I added a variable known as Trap that tells which Pokemon is trapped and for how long. Takedown, Double Edge, and Struggle all do recoil damage. The recoil damage is always 25% of the damage it did. Thrash and Pedal Dance locks the user into using that move between 1 to 3 turns. The lock move does not reduce the PP of the move. After the Pokemon has finished attacking, it will end up confused. Hyper Beam needs to recharge after every use, meaning the Pokemon cannot act the next turn after use. Counter has a low priority, and if a physical move was used on it, they will retaliate with twice the damage that was done with them. Counter itself cannot crit. However, if the physical move did crit, that damage will still be doubled. Absorb and Mega Drain heal the user for 50% of the damage that was done. Whirlwind, Roar, and Teleport will end the battle if it lands, only for wild encounters. Mist creates a mist effect on the user side, meaning that Pokemon on that side cannot have their stats lowered by their opponent. They can, however, lower their own stats. Leech Seed seeds the opponent. Seeded Pokemon takes damage equal to 1/8 of the Pokemon's max HP, and the Pokemon on the user side of the field heals that amount. It does not need to be the same Pokemon that seeded the other. The seed effect goes away when the seeded Pokemon is switched out or faints. Dig and Fly are quite similar, so I'll put them together. When the Pokemon uses either of these moves, they are put in a safe effect, meaning they cannot take any damage. Next turn, they will do the damage the move says. Pokemon that are underground or in the air can be hit by some moves. For example, the move Earthquake can hit underground Pokemon, and it will do double damage. The same is true for the move Thunder for Pokemon in the air. And that was some of the moves that need a bit more explanation and more lines of code for this project. And this is now the end for steps 3 and 4 in the step in battling that you probably forgot about. Now, for step 5, which I'll remind you is check if the Mon who was attacked is still alive. If not, skip step 6. If a Pokemon has fainted, then it cannot attack the Pokemon, the main benefit of going first. Step 6 says if the attacked Pokemon is still alive, do rules 3 and 4 for the opposing Pokemon. I'm not going to go over that again. Step 7 is do in the turn effects, like poison or burn damage. We already discussed this during the 3rd and 4th parts. And finally, step 8. If Pokemon are still alive, return to the initial battle menu. If the opposing Pokemon is dead, reward EXP to the Mons that participated and end the battle if the Pokemon is wild. If the player Pokemon has fainted, pull up the team screen and force the player to switch in any Mon that can be switched in. If no Pokemon can be switched in, then the player wipes and gets sent to the last safe location. I think I summed this up quite well. Now, that's most of the battling done. Now, it's time for the next part. For real this time.
Yeah, baby! That's what I've been waiting for! That's what it's all about! Woo!
The next major mechanic that needs to be added are items. For the idea of how to implement items, let's list out the type of items in Pokemon. There are 5 main types: consumables, Pokeballs, TM/HM, berries, and key items. So what type of items fits the consumable category? Honestly, it's confusing, as basically, it's the throw every item that doesn't fit any other category. It makes sense for items like potions and stones, but includes all held items, which should be in its own category in my opinion. But since it's easier to follow what they did in game, so I guess they all go in consumables. The Pokeball category, do I need to explain what this is? Okay. If you play the games, you should know what each category holds. But I'll list what makes a category unique. The consumable category means that all items in this category can have multiple of the same item, can be sold, and must be used or can be given to a Pokemon. The Pokeball category only works during battle. You cannot use them anywhere else, and they all have the ability to catch Pokemon. TM and HMs cannot be used in battle and cannot be sold. They list off potential moves that a certain Pokemon can learn. HMs in particular will never go away when you pick them up. And key items are mostly story-based items, or items that affect your actual character for abilities on the map, like the bike or the fishing pole. We will be focusing on consumables and Pokeballs for this video. Before we talk about the items, we need to talk about the player's bag. Now the bag is what holds the items, but since items have different categories, it's best that we decide to separate them into the category to make the bag more organized. So we separate the bag into each category and store that item into its category so the bag won't get so crowded as much. Now we need to get the item's functionality, and this is where it gets tricky because not all items can be used everywhere. There are items that can be used anywhere, only in battles, or only out of battles. To do this, we need to further separate the items into effect categories to get where the item can or cannot be used. To start, I'll talk about the items in the heal effects category. This category is intended for any items that heal any part of the Pokemon, whether that be health, status elements, or PP. I also need to worry if the Pokemon is in battle or not in battle, since using an item in battle is considered a move, which means that the other Pokemon does its move as well. So the items in the heal effect category goes into a certain type. Here are the types. HP Restore. Heal any non-faded Pokemon for X amount. Remove status. Remove the status the Pokemon might have. Revive. Give fainted Pokemon health and make them able to battle again. And PP Restore. Give X amount of PP to one or all moves. These are all of the heal effect that any healing items can have. Battle effect items are items that can only be used in battle. These consumables are used to increase the stat of the Pokemon in battles. These are the X items, which all increase that stat by 2 stages. There is also Guard Specs, which gives a miss effect for a few turns, Dire Hit, which increases the chance for crits, Pokédoll, and Fluffy Tail, which guarantees a successful flee for a wild Pokemon battle. Field effect items are items that can only be used outside of battle that affects the map. This includes repels and escape ropes. The EXP effects are items that can affect the Pokemon's EXP or any of the EV values, which includes the HP up, which increases the Pokemon's HP by 1, protein, iron, etc., which increase the EV value of the selected stat by 10, and rare candies. There is one last important consumable that we need to talk about. But first, there is one important factor in Pokemon that I haven't even mentioned yet. And it's one of the core reasons why Pokemon is so beloved. I have yet to mention evolution. When it comes to evolution, even though this evolves into this, they are not the same Pokemon. These Pokemon have completely different stats, moves, and sometimes even different types. Now, because this is an entirely new Pokemon, we need to transfer everything to this new Pokemon, including name, moves, EVs, IVs, nature, and gender. So to evolve the Pokemon, we need to transfer everything to the new Pokemon, and also call the level up function, which will update the new stats, and finally we actually now get the new Pokemon. So, how do we actually evolve the Pokemon? Well, the most common way is by leveling up. When the Pokemon reaches the level where it needs to evolve, it brings you to a screen saying that it's ready to evolve, and then the Pokemon evolves. However, I decided to change this a bit. Instead of following the rules of nearly every mainline Pokemon game, I decided to follow the evolution rules of one of the more recent Pokemon games that came out. No, not that one. This one. In Pokemon Legends Arceus, when a Pokemon wants to evolve, it pops up a notification indicating that the Pokemon is ready to evolve. So instead of evolving the Pokemon when it reaches that level, you get to fully choose when to evolve the Pokemon whenever you want. How would this work in game? Well, once the Pokemon reaches the desired level to evolve, when you go into the team menu, you see the keyword ready, indicating the Pokemon can now evolve. When you select that Pokemon, you see the option at the bottom that usually says to cancel is now replaced with the evolve option. Selecting this will evolve the Pokemon. Note, there is no transition state that would be implemented later. Now that's the basic rule of evolution. However, that's not the only way to evolve Pokemon. To understand this, let's talk about one of the most famous Pokemons, which maybe one of its forms could actually be your favorite Pokemon. So, Eevee is an interesting Pokemon to talk about, considering that it evolves into 8 different Pokemon. And since these 3 don't exist yet, we're just gonna work with these 5. You may be wondering, why am I going so in depth with this Pokemon, considering the fact that you can't even get one in Emerald without trading? Well, I just like this Pokemon, and implementing it would actually make it easier to implement some of the other Pokemon that have a similar evolution style. For Eevee to evolve to any of the 3 Pokemon you see here, you need to give it a stone corresponding to its type. To do this, we're going to go full circle and talk about another item effect, the evolution effect. This effect takes the Pokemon that it can be used on and evolves it into the specified Pokemon. I could have figured out a way to make this work, but it would have been a more confusing and long mess to figure out. So I decided to ask ChatGPT for help, and it suggested something that I haven't utilized much in programming. A map. A map in Java is used to map keys to values, which means all maps take 2 values, the key and the value. That means we can make both these values as integers and assign them to the Pokemon's ID. So the K would be the original Pokemon, and the V would be the evolved Pokemon. This also makes it easier to group the Pokemon together, since maps take 2 values as groups. Which means if you have a Firestone to evolve Eevee and the Flareon, you can also do it for Vulpix and the Ninetales or Growls and the Arcanine. And they all can be in the same line of code, so you don't have to make multiple lines of code. So, when you attempt to use the item, it takes you to the team screen, then it checks all the Pokemon's IDs, and if any Pokemon's IDs match the key, remember is always the first number in the map, then the Pokemon can evolve into that Pokemon, which is always the V in the map. And if you try to use this on any Pokemon that are not in the map, it doesn't do anything. So this effect works for these 3, as well as any Pokemon that evolve with items. But what about these 2? In the games, these 2 evolve by using another hidden Pokemon mechanic that I have yet to talk about. Friendship. What is friendship? Friendship is a hidden value that increases when you do things for your Pokemon, like leveling, battling, or just walking. What does friendship do? It affects damage for 2 moves and evolves some Pokemon. That's it. Okay, in my opinion, friendship is dumb. All it does is waste time, because the fastest way to get your Pokemon to evolve is to just do this. It's completely pointless as well, because for Eevee, it depends on the time of day, because if it's daytime, you get an Espeon, while if it's night, you get an Umbreon. So I hope you really like Espeon, because I don't plan on having any day or night cycle. And don't get me started with you. You're lucky to be a starter in the Pokemon Coliseum games, because if you weren't, then you'd be completely impossible to get in any Generation 3 game. Not only that, but your level up method is completely stupid. Besides, who wants to level up a Pokemon at 3 in the morning?
Oh boy, 3 a.m.
Your Pokedex entry always says you sweat poison, yet you don't even learn a single poison move. The only one you can learn is Toxic, which 90% of all Pokemon can learn. Do you really want to be a poison type or not? Make up your fucking mind! It was so bad that they had to change your Japanese name because it was too offensive. People love this Pokemon so much that it makes me want to tear my eyes out every time I'm trying to do research on it. Your defenses are way too high that every time I face you in battle, you're constantly annoying because you won't fucking die! This Pokemon makes no sense. Yet why do I love it so much? Anyways, since I don't like friendship evolution, I decided to make both Espeon and Umbreon a stone evolution. Like the rest, since even in their generation, when they were introduced, they had stones that perfectly matched the Pokemon. We have the Moonstone that was introduced in the very first generation, and the Sunstone, which was introduced in Generation 2 when they were first introduced. And it also makes the Sunstone a little bit better, since, looking at my notes, the only other Pokemon that the Sunstone would work with is Gloom to battle Awesome, which I'm pretty sure is a Pokemon most people forgot existed. As for other Pokemon that have different evolution methods like trading or anything else, I decided to either make them a leveling evolution or a item or stone evolution, which most of the Pokemon already are, so it just makes it easier. Now after that mini segment, it's time to talk about the other item type, Pokeballs. Pokeballs are items that can only be used in battle, nowhere else. They can only be used in wild battles. How it's determined if you catch the Pokemon is again decided by math. The formula for the catch rate A is 3 times the max HP minus 2 times the current HP all over 3 times the max HP, all that times the catch rate of the Pokemon times the bonus the ball gives times any status the Pokemon may have. Each Pokemon has a specific catch rate, as early game Pokemon are much easier to catch than late game Pokemon. The ball bonus depends on the ball used. Normal Pokeballs have a catch rate of 1, Great Balls have 1.5, Ultra Balls have 2, and Master Balls has 255. It's guaranteed anyway, so just make the number very big. The status condition is a multiplier if the Pokemon has any form of status. 1.5 for paralysis, poison, or burned, and 2 for sleep and freeze. After you get the value, divide that by 100. Then the game chooses a random number between 0 and 1. And if that number is less than the value given, then the Pokemon is caught. Now, there is this whole formula for how many times the ball shakes, but to be honest, I really don't care to learn this formula, because all it does is a small little animation on the screen, which what you really want to know is if the Pokemon was caught or not, so I don't care about learning any of these formulas. Now, we finished this part of the video. The next part is to finish the project. So after everything that I work on, I think it's finally time to stop the video and actually continue to finish this project. I started this project back in December of 2022, and there still is a lot that needs to be worked on. So please enjoy this short monologue when I still have you. The first thing I want to say is that I am a full-time college student, and that's basically taking up most of my time. The other thing is, if I kind of want to do more forms of content, it's probably not going to be all project-based videos. It'll probably be some form of documentary that I find interesting, or just some fun ideas that I come up with. One thing is that if I want to actually do different forms of content, I'm probably gonna change the name of this channel. If the name was actually changed, the original name is Skeleton5853, which is a very old Xbox gamer tag that I use and generally always straight up default to. So this is what I've always known for. Well, that name is basically over 10 years old. I feel like I basically outgrown that phase, and I kind of want to traverse into a different branding if I want to. One of the names I actually like is the name Neon Pixel, which if you don't know are the two names of my Axolotls. Yes, I have Axolotls. Here's a picture of them. And I feel like the name also fits for the type of stuff that I want to do. More of the programming, content, gaming thing, whatever. I probably will also change the profile picture of this channel, which has always been a funny joke to me, and a lot of people don't understand, and it makes sense, but I always find it funny. So if you don't know, the profile picture, if it was changed, it used to look like this, and most people don't know what the hell they're looking at. So let me explain. Basically, one of the first games I fully played around the files and code of is the game SpongeBob Battle for Bikini Bottom, which is one of my all-time favorite games, and no one can tell me that it's bad, because it's not bad. It's one of the best licensed games ever made. A lot of people say so. That's probably don't believe me, look at the speedrunning community, it's huge. Basically, what I did was, I took the model for Squidward and basically put it over Patrick's model. And since the skeleton doesn't match the animation of Patrick's animation, it comes up with this broken mess. And basically, when anyone asks me what's the profile picture based on, I look them dead straight in the eyes and say with a straight face, broken Squidward. And to me, this is always the funniest thing that no one understands. So if I will, like, change the channel completely, I probably will, like, completely change the profile picture as well to something that I would like. So I'll see if I completely change the whole channel or not. Anyway, since I'm, like, fully engrossed in college, don't be surprised if this next part of the video takes a year or two to come out. So anyway, goodbye.